Welcome back to Kotlin Data Structures series. In today's video, we're going to look at stacks. So, what's a stack? A stack is a linear data structure that follows the LIFO principle, last in, first out. So, it has the following operations: push, pop, peek, isEmpty. What exactly is a stack? Well, as you can see, all those plates are stacked on top of each other. All those are stacks. So when you push, you're going to put a plate on any of those stacks. And if you pop, you're going to pick up a plate from any of those stacks, and that's your pop operation. What about peek? Well, if you look at a top element or the plate, top plate of any of these stacks, that's your peek operation. What about isEmpty? Well, if any of these stacks is empty, you're going to know that with isEmpty operation, or all these would be functions in our Kotlin code implementation of this. Okay, so now do you get what exactly a stack is? And it follows the principle last in, first out. So when you push something, it's your last thing, and when you pop that, your last thing is picked up. So your last in, first out, that's how it plays. Okay, now there are two implementations of stack: array implementation and linked list implementation. So the array implementation is for C++ coders, developers, whatever. So those, in that language, you can have the fixed size, but in this one you usually have mutable size, dynamic. So we're not going to do that in Kotlin. What about linked list implementation? Well, it has a dynamic size and it does not overflow. Unlike array implementation where you have a fixed size, so it can overflow because you may encounter new data and you need to add it to that previous data structure, right? Yeah, that can cause an overflow. Yeah, that's about it. What are the applications of stack? Well, in Android, you have this activity backstack, fragment backstack, and navigation component backstack. Well, all these are backstacks. So when you navigate, there are screens. When you go to a new screen, that new screen is pushed to the backstack. And when you push the back button and exit that screen, it's going to get popped from that backstack, All these are backstacks because, well, Android community named it for some reason. What about web browsers? Well, web browsers also use stacks to navigate between pages, and undo and redo operations in editors also use stacks to undo and redo operations. Yep. And backtracking algorithms, well, also in recursion. When you recurse, you repeatedly call a function, and whenever you call a function, you push it onto the stack. You stack all the function calls, and the calls are implemented, or calls are executed one after the other. And well, I can't talk about all the implementation of stacks, there's too many, so never mind. And that's about it. Wait, time complexity. Well, stack has a push time complexity of O1 and pop O1, peek O1, and isEmpty is also O1. So yeah, that's about it. Alright, it's time to code. So you're going to make a node class, and we're going to use template. If you don't know what a template is, well, it allows us to use multiple data types instead of just one for a class. Like, this is going to accept a data of type T. and it's also going to take a node next of node t nullable. It's going to be null. Okay, so what is that? Well, we just created our node class with data. It's going to hold data of any type t, which could be integer, character, boolean. Don't use boolean, please. It's going to be a mess. And double, float. There are so many. Can't name them all. Actually, I could, but you know, linked list stack of type t. And here we go. So first off, you have this private var top of type node. Let's make it int of t, and it's going to be null. Yes. And now let's create the push function. Push function is going to take an item of type t. Just remember that t is just a placeholder for any data type that you want to create a linked list stack of. Okay, so what is push? Well, it's going to add a new node. It's going to make a new node, right? And it's going to do it like this. Yeah. And then the new node is going to point to the top. And the top would be the new node. I think you don't get it, but well, we just created a node and we made it point to the top, and then we made the new node the top of the stack. So it's like you have a plate, you point the plate to the previous stack of plates and you put it at its top, okay? And then you assign the top label to this new node. Then we have pop. Well, pop won't take any parameters, but it will return I could return null. Or maybe not. Okay, so you're just gonna take the top if top is not null. Okay. No, if top would be null, then just print stack underflow and just return null. Okay, so we do need this. Okay, what if it's not null? Well, we're gonna store the popped item like this. Top data. And then we're gonna return no, and then we do this. And return popped item. Good. Okay, so what did you do? Well, you checked if the top is null. You checked if you have a stack, okay? If you don't have a stack, well, just return null. Okay, and if you have a stack, well, we're gonna store the top's data. We're gonna see, you're gonna take the top plate, and then you're gonna point to the next plate, which was right below it. So you did tops next, okay? And then you return the popped item. And then you have fun, push, pop, peak. Let's do peak. Well, in peak 2, you're going to return the top. Return top data. If top is null, we'll just return null. Yep. So when you peak, you're going to look at a top plate. But if the top plate doesn't exist, well, you should just return null. And if it does exist, then just return the top plate's data, whatever you have on it. Yeah, this analogy is getting a little messy. Okay, so you have this peak, pop, and what's left? Push, pop, peak, and check if it's empty. That's pretty simple. Return, it's going to be a boolean. Boolean. And return top and compare it to null. And the null should be lowercase. Yeah, that's almost it. Now let's see how to write a display function. Well, display function will just display all your numbers, all your items. So first, just take the top, call it current, and top. Okay, current is top. It's a variable. While current is a null, this is pretty standard procedure that we've got here. So while the current is null, we just print like so. Where's the dollar sign? Damn it. There we go. Okay, so current dot data. Yeah. We're gonna print that and we're gonna add some space. And current equals current's next. So you do gotta move to the next plate, right? After seeing what's on one plate. Well, you could also think of them like a cards stack. Like what if you had these cards, you know, playing cards, and you pick them up one by one, and then you see the data on all of them, one after the other. Okay, so that's our class for node and linked list. Done. Now let's define a stack. Of type int. Yep. Done. Don't worry about this, it's just referencing it from line 7. Forget about it. You just have to write linked list stack int and this. Okay, now let's add something to our stack. Let's add 100. And then add 20. Then add 30. Finally add 90 or 69. Okay, so done. Now let's display. Exactly as it should be. Whatever was pushed at the end, it'll be displayed at the, because it's at the top. It'll be displayed first. So you see 69, 30, 20, and 100. Because you push them, because it's a last in, first out data structure, so whatever you push in the end will be at the top. So it's 69, 30, 20, and 100. What if we pop something? Stack dot pop. Okay. It's going to return 69 because it's at the top. It's going to pop the top. Yep. And then we have what? Display pop peak. Yeah, we have peak. It's going to now it should display 30 because we just popped 69. Like so. What else? isEmpty. Yeah, let's check isEmpty. It's going to return false. False. Yep. Okay, now let's just empty the stack. Like this, because there were only 2 elements left. And then check stack is empty. Wait, what? Stack dot display. Okay. Well then, go away 100. And now let's check if it's empty again. True. And we're done. Thank you for watching. Meet you in the next video.